As we saw in the preceding example, it's possible to use the elements of an array as counters. And in this next example, we're going to do the same thing, this time to analyze some survey results. And we have a little problem statement up on the screen here. 20 students were asked to rate on a scale of 1 to 5 the quality of the food in the student cafeteria, with 1 being awful and 5 being excellent. Place this 20 responses into an integer array and determine the frequency of each rating. So as you might imagine, we're going to have an array of values, and kind of like we did with the rolling of the six-sided die 6 million times, that array of values, each of the values will be used as an index into our frequency array once again in this example, and we will then increment the appropriate counter for each response to the survey. Now, as you might expect, typically this type of data would be entered into an app by the user typing at a keyboard, or perhaps it might be read from a file containing all of the responses. And in many earlier examples, we had cases where there was user input being received by the program, and we didn't do any kind of input validation in those programs. We always were assuming the user entered an appropriate integer or floating point number in those earlier examples. And of course, it's not a good idea in an industrial strength app to assume anything about the user's input. So what we're going to do is open up our student poll program, and in this program we will have the possibility of an exception occurring, and we're going to demonstrate for the first time how to deal with that exception. So as you can see here, we have just a simple class containing main once again. That's the whole class definition. And inside of main, we have an integer array called responses, which we've hard-coded with all of the survey responses in the range 1 through 5, with the exception of the last item in that array. The 20th element of the array at position number 19 has the value 14. Now, each of the values inside of this array is going to be used as an index into our frequency array, which has only 6 elements with indices from 0 through 5. We're going to be ignoring element 0, and any value outside the range 1 through 5 would cause us to access an element that does not exist in the frequency array. And certainly position number 14 does not exist in the frequency array. So we're kind of doing this on purpose here to demonstrate the concept of exception handling and to show you what happens if you don't validate your data to make sure that it's appropriate for a given app. Now, lines 16 through 28 are going to summarize the survey results by incrementing the appropriate frequency counter using the statement at line 20. And you can see for whatever the counter value answer is at a given time, we're going to use that as the index into the responses array. We're going to grab an appropriate element from that array, and whatever that value is, we're going to use as the index into the frequency array. So for example, when answer is 0, responses sub-answer is going to be the value 1, the first element of the array, which means that line 20 would increment frequency sub 1. When answer becomes 1, responses sub-answer would be the value 2. That would cause us to increment frequency sub 2. And when answer is 2, then the value of responses sub-answer will be 5, and we'll increment frequency sub 5. And we'll continue doing this through all of these values in the range 1 through 5, until eventually we get to the value 14, which is out of range. Now, in C#, when you attempt to access an index that's outside the range of elements for a given array, the runtime throws an exception, which is an indication of something that's gone wrong at execution time. And if you use the so-called try-catch exception handling mechanism that's built into C#, you can trap that problem at execution time and at least try to recover from it, if not just log an error of some sort to indicate that there was a problem so that you can go back and debug it at a later time. Now, with user input, if we're validating our data, then hopefully such an exception in this example would never happen, but we're not validating first that all of the values in the responses array are correct. Therefore, we are going to have an attempt to increment an element that does not exist. So if I go ahead and run this for a moment in debug mode, let's go ahead and start it up. So I've purposely put my break point at line 20, which means I'm going to be able to see each of the 20 executions of this statement. And throughout the processing, we'll be able to watch the frequency elements get incremented appropriately. Again, element 0 will be ignoring, so for the first 19 values in the responses array, these last 5 positions in the frequency array will get incremented. So if I go ahead and hit the continue button, it's going to continue to the next breakpoint, which will get us back to line 20 again because I'm in a loop. So let me go ahead and hit continue, and we can see that the first element of the responses array caused us to increment position 1 in the frequency array. And we can confirm that that was correct by looking at the first element of responses, seeing that it was a 1, and that's causing us to increment frequency sub 1. We can see that the next item is a 2, so we expect frequency sub 2 to get incremented, and then the next item is a 5, so we would expect frequency sub 5 to get incremented in the next 2 iterations. So I'll hit continue, and we can see frequency sub 2 got incremented, and I'll hit continue again, and we can see frequency sub 5 got incremented. Now, I'm going to keep doing this to get us to the point where we can look at the value in the responses array that has the value 14. So let me go ahead and do that. And you can see down here the answer value incrementing to indicate each iteration of the loop. So we're going to keep doing that all the way up until answer is 19, which is the last element of the frequency array. Now, at this point, I can see that answer is 19. By the way, remember you can hover over any variable inside the IDE to see what its values are. In the case of an array, it gives you a plus sign so you can see all the elements. And right now, what it's showing me is the values at each of these different positions in the array. So if I scroll down here, you can see that the position number 19 contains the value 14. So responses sub answer at the moment is going to be giving us back the value 14 because that's the position that we're at in the responses array. And when I try to execute this statement, what's now going to happen, and I'll do a step over for this purpose, is that an exception is going to occur. Notice that the exception now shows up as a local inside the locals window, and I can expand that and I can see some information about the exception here. It's telling me that the index was outside the bounds of the array, and it also has all sorts of other information built in here to show us what was going wrong. For example, you can see that there's something called stack trace, and that actually lists out all of the functions that were on the function call stack at the time that the exception occurred, and that helps you with tracking where the problem was in your code. And you can see if you click this item here and hover over it that the problem occurred at line 20. That's all the way at the far right side of the tooltip. It tells you the precise line number where the problem occurred, and that helps you focus on that problem in terms of debugging as well. Now, what's going on here in the body of the for loop is that we have a try-catch sequence. In a try-catch sequence, whatever you put in the try block is code that you are going to try to execute, and that might cause a problem. You also put in the try block any code that you would not want to execute if that problem occurred. So for example, if we were displaying some information perhaps based on the counter that got incremented, we might have an output statement between lines 20 and 21. And what we might do there is say, don't display the output statement if this line 20 statement didn't execute correctly. And the reason for that is the try block terminates immediately when an exception occurs. The exception is then passed down to the catch blocks, of which there can be many following a given try block, and it performs a switch-like logic to figure out if the type of the exception that was thrown matches up with one of the catch handlers. In this case, the type of the exception that's going to be thrown because of the fact that we're accessing an out-of-range element is an index out-of-range exception, and that is the same type that we are catching here at line 22. The exception mechanism then assigns to the reference EX, which is just a variable name that you can choose. It assigns to that the exception object that got thrown by, in this case, the runtime. And then we can use that exception object to access things like its message property, which indicates the problem that occurred. And this string here, index was outside the bounds of the array, is the value of that message property. In fact, you can see that down here in the debugger as well. So in this case, what we're going to do is display an error message, and we're also going to tell you what the value was of responses sub 19. Now, when you're in the process of dealing with an exception, that is, executing code inside of a catch handler, reaching the closing curly brace of the catch is what's going to indicate to the system that the exception has been handled. So as I hit step over in this case, we're going to wind up hitting the end of the for loop, which will of course cause us to check and see if the loop should continue executing. And because that was the last element of the array, when I increment the answer and then test the condition, the loop is going to terminate, at which point we're going to start displaying the results of this program. Now I'm going to go ahead and hit stop on the debugger and just run the program through to completion so that you can see the error message that we displayed indicating that responses sub 19 was the value 14, and of course that's out of range for a frequency. And if you look at our summary of the results, in this program what we simply did was to ignore the value 14. So you can add these up in the right hand column and see that there were a total of 19 valid responses. Now, in a real program, what you probably would have wanted to do was to first validate all the data to make sure that it was correct for the type of processing you were doing, and then, if not, indicate to the user that in fact something was incorrect, in our case, an out-of-range value. Now let's go back to the try-catch for a moment and talk about that in a little bit more detail. So in a try block, like I mentioned, you put any code in there that you want to try to execute because it might cause a problem, and any code that should not execute if that problem does occur. In the catch handlers, you put the code that deals with the problem. In our case, quote unquote, dealing with the problem was just to display an error message. And sometimes that's all you really can do. You might log the error message for a programmer to go back and look at later to see what was causing the problem. Now, you can have many catches following a given try block. There can be nothing between the try block and the first catch, and nothing between any catch and its subsequent catches other than white space. If there are multiple catches, only one of them will ever execute if there's a match with the type of exception that was thrown. And when we get to our lesson on exception handling, we'll talk about what happens if there's not a match. That results in a process called stack unwinding that for certain types of programs may result in the program terminating, or may result in a particular thread of execution within the program terminating. Again, it depends on the type of program. So you can have multiple catches. When a given catch finishes executing because of a matched type of exception, the exception is considered handled, at which point you simply move on to the next valid statement in sequence. For us, because the end of the catch is followed immediately by the end of the for, that would mean that we simply go and increment the counter.